Okay, we have some math here on the board. We have the square root of the square root of 289 minus square root of 288. And I've been seeing a lot of problems like this on YouTube, and I really like this. The thing I like about this, it kind of fooled me the first time, is I could see that it's going to be a small decimal number, right? Just because 289 and 288 are so close together, I could estimate it, but I didn't realize you could get kind of a compact, clean expression for this. So what I'm going to do for my first step is just notice that 289 is actually 17 squared. So the square root of 17 squared is just going to give me 17. So I can rewrite this as 17 minus the square root of 288. And there's a number of different ways that you can approach problems like this. But the way I approach this usually is I'm thinking inside the square, we want this whole thing to be a perfect square. Typically with the embedded square root, what I look for is something of this form. So we could say, if we have something square root of a minus b, if this is squared inside the square root, well then our solution is going to be this. And what we can do is let's just multiply this out and see what we get. So if we square that out, we're going to have a plus b minus 2 square root of ab. And then what I do is try to line it up. If I just kind of look at this side by side, and we write this out. And then what we're saying here is that we want 17 to be a plus b. That's nice. But the problem we have here is we don't have a 2 here. We need this 2 in front. If we want this to really line up perfectly, we're going to want a 2 there. I mean, the other way you could do is I could bring this in as a 4. But what I'd rather do is take this 288 and factor out a 4. So I can write 288. 288 is the same thing as 4 times 72. So when we look at, if we write the square root of 288 as 4 times 72, then we could take the square root of 4 and we can write this as 2 times the square root of 72. Now let me put this back into my radical. So we're going to write this as 17 minus 2 square root of 72. And now we're getting closer because we're saying we want 17 again to be a plus b, and we want 72 to be a times b. And what we can do is look at the factorization of 72. So 72 is going to be 3 squared times 2 cubed. And you could mess with this, but you'll notice that if we just have this as 9 times 8, 9 times 8 is 72, but 9 plus 8, if we look at our a plus b, 9 plus 8, that gives us 17. So therefore, going back to this formula, I can write this whole thing. I can write this as square root of 9 minus square root of 8, and we can square this inside the radical. And just notice that I have the larger number to the left so that this number is positive. And that's because we know, looking at this, we can tell if this is going to be a positive number, so we want the positive number here. So knowing that, we can kind of cancel the radical with the square, and we can drop our absolute value as we know we want it to be positive, and we end up with the square root of 9 minus square root of 8. And we can simplify this. Of course, square root of 9 is going to be just 3. And I can write, we could leave square root of 8, but I can write it as 2 square root of 2. And that's going to be my solution. And like I said, initially it's kind of interesting that we can get kind of a clean, simple expression like this. And I don't have my calculator handy, but square root of 2 is 1.414. 2 times that, so it's like, okay, 2.828. And so this is going to be like a little less than 0.2, and that kind of makes sense for this kind of expression. So anyway, good problem today. We'll stop it there. Thanks everyone for watching. Have a great day.